No drilling rigs, no power equipment, no modern machinery. Out on the frontier, where the nearest water source might be miles away and drought could kill an entire settlement, families faced a life-or-death challenge: find water underground or watch everything they'd built turn to dust. The wilderness offered no guarantees, no easy solutions, and no second chances for those who couldn't master the ancient art of well digging. They needed techniques that could locate water in unknown terrain. They needed tools that could penetrate rock, clay, and hardpan using only muscle power. They needed methods that could create reliable water sources using nothing but primitive equipment and generations of accumulated knowledge. Every decision mattered. One wrong location, one collapsed well shaft, one contaminated water source, and a family could lose everything they'd worked to build. The difference between a successful well and a dry hole was often the difference between a thriving homestead and an abandoned grave. The frontier families who survived in the harshest environments had perfected well-digging techniques that were more sophisticated and reliable than many modern methods. Systems that could locate and access groundwater using only hand tools and traditional knowledge. But how did frontier families locate underground water without any modern equipment? Which forgotten techniques allowed them to dig through solid rock and unstable soil using only primitive tools? How did they prevent cave-ins and contamination while working in dangerous conditions? And what well-digging methods were so effective that they remained superior to modern alternatives? Today, we're exploring the ingenious well-digging methods that provided frontier families with the most precious resource in the wilderness: clean, reliable water that meant the difference between life and death. My name is Sam, and this is Wild America. Between 1750 and 1900, frontier families developed well-digging systems that were marvels of practical engineering and geological understanding. These weren't simple hole-digging operations. These were sophisticated water location and extraction systems that could find and access groundwater in the most challenging conditions using only traditional tools and ancestral knowledge. Water location and site selection, reading the hidden signs, 1750 to 1800. The success of any well depended entirely on choosing the right location, a skill that combined scientific observation with traditional knowledge passed down through generations of water finders. Frontier families developed sophisticated techniques for locating underground water that were more accurate than many modern methods. The geological observation techniques required understanding how different rock formations, soil types, and surface features indicated the presence of underground water. Frontier families learned to read the landscape like a book, identifying the subtle signs that revealed where water flowed beneath the surface. Limestone formations often contained underground caverns filled with water, while sandstone layers could hold water like massive underground sponges. Clay layers acted as barriers that trapped water above them, creating perched water tables that could be accessed with shallow wells. The vegetation indicator systems used plant growth patterns to locate underground water sources. Specific plants and trees grew only where their roots could reach groundwater, creating natural markers that revealed the location and depth of water tables. Willows, cottonwoods, and certain grasses indicated shallow water within 10 to 15 feet of the surface. Elder bushes and wild cherry trees often marked underground streams or springs. Even the health and size of common trees could indicate water availability. Larger, healthier trees in otherwise dry areas often marked underground water sources. The topographical analysis methods helped frontier families understand how surface features related to underground water flow. Water naturally flowed downhill underground just as it did on the surface, following predictable patterns that could be read by experienced water finders. Valley bottoms where multiple ridges converged often contained underground water sources. Natural depressions that stayed green during dry periods indicated shallow groundwater. The intersection of different geological formations often created conditions where water accumulated underground. The seasonal observation protocols tracked how water availability changed throughout the year and during different weather patterns. Frontier families learned to observe how springs, streams, and surface water behaved during wet and dry seasons, providing clues about underground water sources that remained consistent year-round. Areas where surface water disappeared into the ground often indicated underground flow that could be accessed with wells. Morning dew patterns could reveal underground moisture, with heavier dew often appearing over underground water sources. The dowsing and water witching techniques used traditional methods that many frontier families swore by for locating underground water. While controversial, these methods were widely practiced and often successful, using forked sticks of willow, peach, or witch hazel to detect underground water sources. Experienced dowsers claimed they could not only locate water, but also estimate its depth and flow rate. Whether through geological sensitivity, unconscious observation of environmental clues, or other factors, experienced dowsers often located water where other methods failed. The test hole procedures allowed frontier families to verify water location before committing to full well excavation. Small test holes, typically 3 to 4 feet deep and 18 inches wide, could be dug quickly to check soil moisture, water table depth, and water quality before investing the enormous effort required for a full well. These test procedures prevented wasted effort and resources. Multiple test holes in a small area could reveal the direction of underground water flow and help pinpoint the best location for a permanent well. The neighbor consultation networks shared water location knowledge within frontier communities. Families who had successfully located water shared their knowledge with newcomers, creating community databases of geological information that improved everyone's chances of finding water. This cooperation was essential for community survival. Experienced settlers could provide invaluable information about local geology, seasonal water patterns, and the depth of successful wells in the area. The seasonal timing strategies determined the best times of year for well location and digging activities. Water tables fluctuated seasonally, and the best time for locating permanent water sources was often during the driest part of the year when only the most reliable sources remained active. Late summer and early fall were typically the best times for water location when temporary water sources had dried up and only permanent underground sources remained accessible. The multiple source planning ensured that frontier families didn't depend on a single water source for survival. Experienced families planned multiple wells or backup water sources to protect against well failure, contamination, or seasonal variations in water availability. This redundancy was essential for long-term survival and provided security against the many things that could go wrong with a single water source. The documentation and mapping systems recorded successful water locations and geological information for future reference. Frontier families created informal maps and records that preserved water location knowledge for their descendants and neighbors. These records included information about well depth, water quality, seasonal variations, and construction techniques that had proven successful in local conditions. By 1800, frontier families had developed water location systems that could reliably find underground water in challenging terrain using only traditional observation methods and accumulated knowledge. These techniques formed the foundation for successful well digging and represented sophisticated understanding of hydrology and geology that rivaled modern scientific methods. Excavation Techniques: Digging through earth and stone, 1800 to 1850. Once water was located, the real challenge began: excavating a well shaft through whatever geological obstacles lay between the surface and the water table. Frontier families developed sophisticated digging techniques that could penetrate any material using only hand tools and human power. The hand digging methods formed the backbone of frontier well excavation, using specialized tools and techniques that maximized efficiency while minimizing danger. The basic technique involved one person digging in the bottom of the well while others hauled dirt and rock to the surface using buckets and ropes. This system required careful coordination and constant attention to safety. The digger worked in shifts, typically no more than 2 hours at a time, due to the physical demands and safety concerns of working in a confined space. The tool selection and modification processes ensured that frontier families had the right equipment for different geological conditions. Standard shovels and picks were modified for well digging, with longer handles for deeper work and specialized shapes for different soil types. Mattocks with narrow blades could work in confined spaces, while broad-bladed tools moved loose soil efficiently. Specialized digging bars, some weighing 20 pounds or more, could break through hardpan and fractured rock. These tools were often custom-made by local blacksmiths to meet specific geological challenges. The rock breaking and removal techniques handled the solid rock formations that often blocked access to underground water. Frontier families used fire-setting methods, where fires were built against rock faces and then doused with cold water to crack the stone. This thermal shock method could fracture even the hardest rock formations. Steel wedges and hammers were used to split cracked rock into manageable pieces. The wedge and feather method used multiple wedges driven into natural cracks to split large rocks systematically. The soil stabilization methods prevented cave-ins and maintained safe working conditions in unstable soil. Frontier families learned to recognize dangerous soil conditions: sandy soils that could collapse without warning, clay soils that became unstable when wet, and mixed soils that could shift unpredictably. They developed techniques for shoring up well walls using stones, logs, and other materials. Temporary cribbing using short logs could support unstable walls during excavation, while permanent stone lining provided long-term stability. The water management systems handled the groundwater that was encountered during digging. As wells approached the water table, seepage and flooding became major challenges that could halt excavation or create dangerous working conditions. Frontier families developed bailing techniques using leather buckets and hand pumps to remove water as fast as it entered the well. Temporary drainage methods, including small sumps dug at the bottom of the well, allowed work to continue even in wet conditions. The debris removal and hauling systems efficiently moved enormous quantities of dirt and rock from the bottom of deep wells to the surface. This required sophisticated pulley systems, strong ropes, and carefully coordinated teamwork. A typical well might require removing 50 to 100 tons of material. The deeper the well, the more complex the hauling system needed to be. Multiple pulleys could reduce the effort required to lift heavy loads, while windlasses provided mechanical advantage for continuous hauling operations. The ventilation and air quality management ensured that workers could breathe safely in deep, confined spaces. Deep wells could accumulate dangerous gases like carbon dioxide or hydrogen sulfide, or become oxygen depleted, creating life-threatening conditions. Frontier families developed ventilation techniques using bellows and air tubes to maintain safe working conditions. Candles or oil lamps served as early warning systems. If the flame went out, the air was too dangerous for human occupation. The shift work and labor organization systems managed the enormous physical demands of well digging. A typical well required weeks or months of hard labor, often involving entire families and community cooperation. Work shifts were carefully planned to prevent exhaustion and maintain safety. Rest periods were mandatory, especially for workers in the well bottom. Labor sharing allowed communities to complete wells that would have been impossible for individual families. The progress measurement and depth tracking methods monitored well depth and progress toward the water table. Frontier families developed techniques for measuring well depth accurately using weighted ropes and tracking progress toward estimated water levels. This information was essential for planning work schedules, estimating completion times, and determining when to modify excavation techniques. Depth measurements also helped determine when wells were deep enough to reach reliable water sources. The safety protocols and emergency procedures protected workers from the many dangers of well digging. Cave-ins, falling objects, gas accumulation, and equipment failures could kill or injure workers instantly. Frontier families developed safety procedures that included constant communication between surface and bottom workers, emergency evacuation procedures, and rescue techniques for workers trapped in collapsed wells. Safety ropes and harnesses were mandatory for all workers entering the well. The quality control and inspection systems ensured that wells were dug properly and would function reliably for years. Proper well construction required attention to detail and adherence to proven techniques. Quality control during construction prevented problems that could make wells unusable or dangerous. Regular inspection of well walls, support structures, and excavation progress ensured that problems were identified and corrected before they became serious. The weather adaptation techniques allowed well digging to continue in various weather conditions. Rain could flood wells and make excavation impossible, while freezing weather could make tools brittle and soil difficult to work. Frontier families developed techniques for protecting work sites from weather, managing water infiltration during storms, and adapting their methods for different seasonal conditions. By 1850, frontier families had mastered excavation techniques that could dig wells through any geological formation using only primitive tools and human power. These techniques represented the pinnacle of manual excavation technology and remained effective even in the most challenging conditions, often producing better results than modern mechanical methods. Well construction and lining. Building permanent water systems, 1850 to 1875. Creating a functional well required more than just digging a hole. It required sophisticated construction techniques that would provide clean, reliable water for decades. Frontier families developed well construction methods that created permanent water systems using only local materials and traditional techniques. The stone lining techniques used carefully fitted stones to create permanent, stable well walls that would last for generations. Stone lining prevented cave-ins, filtered water naturally, and provided structural integrity that could withstand decades of use. The stones had to be selected for proper size and shape, often requiring custom cutting and fitting. Flat stones were preferred for their stability, while rounded stones required careful placement to prevent shifting. The lining typically extended from the bottom of the well to several feet above the water table. The log cribbing methods provided alternative well lining for areas where suitable stone wasn't available. Log cribs used interlocked wooden frameworks that provided structural support while allowing water to enter the well. These wooden linings required careful construction using notched logs that fit together tightly. The logs were typically made from rot-resistant woods like cedar, oak, or chestnut. Proper log cribbing could last for decades if constructed correctly and maintained properly. The clay and mortar sealing systems prevented contamination and maintained water quality by sealing the upper portions of wells against surface contamination. Clay and lime mortar were used to create watertight seals that prevented surface water, debris, and contaminants from entering the well. The sealing typically extended from the surface down to below the frost line, ensuring that surface contamination couldn't reach the water supply. Proper sealing was essential for maintaining water quality and preventing illness. The gravel pack and filtration layers created natural water filtration systems that improved water quality and prevented sediment from entering the well. Carefully graded gravel and sand layers around the well bottom filtered water naturally and prevented fine particles from clouding the water supply. The filtration system typically consisted of multiple layers with coarse gravel at the bottom and progressively finer materials toward the top. This natural filtration system could remove most sediment and many contaminants. The wellhead construction and protection systems created secure, weatherproof access to the well while preventing contamination and accidents. Wellheads included covers, windlasses for hauling water, and protective structures that kept the well clean and safe. The windlass system used a horizontal cylinder with a rope or chain to raise and lower buckets. Proper wellhead construction was essential for long-term well function and safety. The cover had to be secure enough to prevent accidents while allowing easy access for water collection. The drainage and runoff management systems prevented surface water from contaminating the well or causing structural problems. Proper grading and drainage around the wellhead directed surface water away from the well and prevented erosion or contamination issues. Drainage ditches, berms, and surface treatments ensured that rainwater and snowmelt didn't pool around the well or seep into the water supply. The depth optimization and water level management techniques ensured that wells provided adequate water while maintaining structural integrity. Wells needed to be deep enough to reach reliable water sources, but not so deep that they became unstable or difficult to maintain. The optimal depth depended on local geology, water table depth, and seasonal variations in water availability. Proper depth management ensured consistent water supply throughout the year. The testing and quality assurance procedures verified that completed wells provided clean, safe water in adequate quantities. Frontier families developed testing methods for water quality, flow rate, and reliability that ensured their wells would meet family needs for years to come. Water testing included visual inspection, taste testing, and observation of how the water affected livestock and crops. Flow rate testing determined whether the well could provide adequate water during dry periods. The maintenance access and repair systems built into well construction allowed for ongoing maintenance and repairs without major reconstruction. Wells needed periodic cleaning, repair, and maintenance, so construction methods included provisions for accessing and maintaining the well system. Removable sections of lining, access points for cleaning equipment, and repair procedures were planned during initial construction. The backup and redundancy systems provided alternative water access methods in case of equipment failure or other problems. Multiple access points, backup hauling systems, and alternative water sources ensured that families wouldn't lose water access due to equipment problems. Backup systems might include hand pumps, alternative windlass systems, or emergency water storage. The winterization and freeze protection methods adapted well systems for use in freezing climates. Wells in cold climates required special construction techniques to prevent freezing and maintain water access throughout winter months. Insulation, deeper construction, and heated well houses protected water systems from freezing temperatures. By 1875, frontier families had developed well construction techniques that created permanent, reliable water systems using only local materials and traditional methods. These construction techniques produced wells that functioned effectively for decades and provided the foundation for permanent settlement and community development. Water management and maintenance, sustaining the life source, 1875 to 1900. A completed well was only the beginning. Maintaining clean, reliable water required ongoing management and maintenance that could preserve water quality and well function for generations. Frontier families developed comprehensive water management systems that maximized the value of their precious water sources. The water quality monitoring and testing systems ensured that well water remained safe for drinking and household use. Frontier families learned to recognize signs of contamination, seasonal changes in water quality, and potential health hazards. Visual inspection could reveal cloudiness, discoloration, or foreign matter in the water. Taste and smell testing could detect contamination that wasn't visible. Regular testing and monitoring prevented waterborne illness and maintained family health. Families also observed how their water affected livestock, crops, and cooking to detect quality changes. The cleaning and maintenance schedules kept wells functioning at peak efficiency and prevented problems that could make wells unusable. Regular cleaning removed sediment, debris, and biological growth that could contaminate water or reduce well capacity. Annual cleaning typically involved removing all water from the well, scrubbing the walls and bottom, and removing accumulated sediment. preventive maintenance was much easier and less expensive than major well repairs or reconstruction. The contamination prevention and protection protocols safeguarded wells against the many sources of contamination that could make water unsafe. Proper wellhead sealing, drainage management, and access control prevented surface contamination from reaching the water supply. Livestock were kept away from well areas to prevent contamination from animal waste. Proper disposal of household waste and sewage prevented contamination of groundwater sources. The seasonal management and winterization techniques adapted well operation for different weather conditions and seasonal challenges. Winter operation required special techniques to prevent freezing, including insulation of wellheads, heated well houses, and modified hauling procedures. Summer management focused on maintaining water levels during dry periods and preventing contamination during hot weather when bacterial growth was more likely. The water conservation and storage systems maximized the value of limited water supplies and provided backup water during dry periods. Frontier families developed techniques for storing water safely in cisterns, barrels, and other containers. Water conservation practices included reusing water for multiple purposes, collecting rainwater, and using water efficiently for household tasks. Storage systems provided backup water during well maintenance or dry periods. The equipment maintenance and repair protocols kept well equipment functioning reliably and prevented equipment failures that could cut off water access. Ropes, buckets, windlasses, and other well equipment required regular maintenance and occasional replacement. Rope inspection and replacement prevented accidents and equipment failures. Windlass maintenance ensured smooth operation and prevented mechanical problems that could make water collection difficult or impossible. The expansion and improvement projects upgraded existing wells to meet growing family needs or changing conditions. As families grew or water needs increased, wells could be deepened, improved, or supplemented with additional water sources. Well deepening techniques could access deeper water sources during drought periods. Improved filtration systems could enhance water quality. Additional wells could provide backup water sources or serve growing communities. The community cooperation and sharing systems allowed multiple families to benefit from major well projects and shared the costs and labor of well construction and maintenance. Community wells served multiple families and required cooperative management and maintenance. Shared wells reduced individual costs while providing reliable water for entire communities. Cooperation agreements established usage rights, maintenance responsibilities, and cost-sharing arrangements. The emergency procedures and backup plans provided alternative water sources during well failures, contamination events, or other emergencies. Frontier families needed backup water sources and emergency procedures to survive well problems or water shortages. Emergency plans included alternative water sources, water rationing procedures, and well repair techniques. Backup water sources might include springs, streams, or neighboring wells. The knowledge transfer and training systems ensured that well management knowledge was passed down through generations and shared within communities. Proper well management required specialized knowledge that needed to be preserved and transmitted to maintain water security. Training programs taught young people well maintenance techniques, water quality assessment, and emergency procedures. Knowledge sharing within communities improved everyone's water management capabilities. The record-keeping and documentation systems tracked well performance, maintenance activities, and water quality over time. These records helped families understand their water systems and plan for future needs and improvements. Documentation included well construction details, maintenance schedules, water quality observations, and equipment replacement records. This information was valuable for troubleshooting problems and planning improvements. Water was life itself, wrote frontier chronicler Samuel Henderson in 1887. A family with a good well could survive anything the wilderness threw at them. A family without water was already dead. They just didn't know it yet. Every drop was precious, every well was a miracle, and every technique was tested by generations who lived or died by their ability to find and keep clean water. The techniques we've explored in videos like the surprising trick settlers used to find water in the wild, and how frontier settlers built wildlife ponds with just hand tools demonstrate that frontier families developed complete water management systems using only traditional methods and primitive tools. The well digging capabilities developed by frontier families prove that with knowledge, proper techniques, and traditional equipment, it's possible to create reliable water sources in the most challenging conditions. My name is Sam, and this is Wild America.